All right, let's go ahead and pray. Dear Heavenly Father, we just thank you for the day. Thank you for the blessings you've given us. Thank you for the students here. Thank you for it being Friday. Just pray you may help the students, Lord, in their classes as we finish up the third quarter of this next week. Just guide and lead everything we do. In Jesus' name, amen. All right, your homework. Your homework was
27 to 39 odd.
27 to 39 odd. Anybody have any questions?
What's the antiderivative of negative 6 over 5? Exponent of 6. There. Can we do number 31? There you go.
We got the integral from 1 to 32, is that correct? X to the negative 5, x to the negative 6 fifth. Alright, how do we take the antiderivative?
Add 1 and then divide by.
So when I add 1 to negative 6 fifths, I get?
Negative 1/2.
Huh?
Negative. What?
Add
Negative
1.
1/5.
Negative 1/5.
That's what I meant to say. I didn't say 1/5.
And then we're going to divide by
negative 5, I guess. Oh, wait, what? Oh, 1 over 5? Oh, so
divide by a fraction, you multiply by its
reciprocal.
So now we got negative 5, 32 to the negative 1/5 minus negative 5, 1 to the negative 1/5. To the negative 1/5 is? Nope. What's 32 to the 1/5? 1/5. Okay. 32 to the negative 1/5 is 1/2. 32 to the 1/5 is 2, but the reciprocal is 1/2. Times 5, negative 5 over 2. And 1 to the negative 1/5. 1 times negative 5 is minus negative 5 is plus. Alright? So negative 5/2 plus 5 is 5/2. Any other questions? Is that it? Everybody good? All right, pass those forward, please. What happened, son?
I dropped him after I came home last night.
Noah?
Hold on.
Oh, that's really awful. I forgot to give you the last page of the test yesterday. I was gonna give it to you after art class,
Oh,
and I never did.
I forgot about too, so. Go ahead and give me the rest of the whole thing, and I'll bring it back to you.
Oh. I'll find it when I give it to you later.
All right, turn to page 303. Let's look at that exercises 41 to 44. It says find the total area of the region between the curve and the x-axis of y equals 2 minus x. Well, when they say total area, that's where we need to make sure that we find out, does it cross the x-axis? Do I have part of it below the x-axis or part of it above? So we're gonna have 2 minus x. That is that graph. And they're finding the area between 0 and 3. So I have some below the x-axis and some above. So therefore, I want the integral from 2 minus x from 0 to 2 minus the integral from 2 to 3 of 2 minus x. I do a minus because I know the one below is negative, so I want to make that positive, so I do a minus. And I need to make sure I have this written correctly. Those are derivatives. So therefore, I have the integral of the derivative of 2 minus x, which is
2.
I'm sorry, the antiderivative of 2 minus x. I said that wrong. The antiderivative of 2 is
2x minus x squared.
close.
Oh, wait.
Antiderivative of x is
Okay, what, x?
Whatever, x over
1 half x squared.
Alright, so x squared over 2. Alright? And one nice thing is that you get the same function, so it's the same antiderivative. So here we got 2 times 2 minus 2 squared over 2 minus 0 minus 2 times 3 minus 3 squared over 2 minus 4 plus 4 over 2. So we just plug it in. Alright, 4 minus 2 squared over 2 is? 4 minus 2 is? 2. Minus 6. 9 over 2. Minus 2. Alright, 6. What's that?
11 over 2.
4. Negative 1 half. Correct? 6 minus 2 is 4. 4 is the same thing as what over 2? 8 over 2. 8 over 2 minus 9 over 2 is negative 1 half. So 2 minus negative 1 half is
It's 5 halves.
5 halves. Alright, so we want to, sorry Grace, we want to be able to graph a rough sketch to find out where is the graph below the x-axis, where is the graph above the x-axis. Let's look at number 43. Y equals x cubed minus 3x squared minus plus 2x, and we are between 0 and 2, is that correct? Yes. Alright, so we want to graph this to find out, alright, is there somewhere between 0 and 2 that this is below the x-axis or above the x-axis? Well, if I factor out the x, I get x squared minus 3x plus 2. That's x. Factors of x squared minus 3x plus 2 is x minus 2x minus 1. So when I look at this graph, I have a 0 at 0, I have a 0 at 1, and I have a 0 at 2. Cubic function looks like what? Alright, down, up. So we're going here, here, and here. So I do have part of the graph that's below the x-axis. So therefore, I'm gonna take the integral of x cubed minus 3x squared plus 2x from 0 to 1 minus, oops, do this right, the integral of x cubed minus 3x squared plus 2x dx from 1 to 2. Alright, so the antiderivative of x cubed.
X to the
Of 3x squared.
X to the third minus X to the third.
2x
Minus X, right? Or plus it.
Alright, so if we put 4 in, let me continue over here,
4 or 1?
I'm sorry, 1, alright. So we get 1/4 minus 1 plus 1, and when I put 0 in, I get 0, so now I got minus, I put 1 in, 1/4 minus 1 plus 1, and, oops, I'm sorry, I just put 2 in. Put 2 in, I get
4
4
minus 8
minus 8
plus 4.
plus 4 minus 1/4 plus 1 minus 1. Alright, what do I get here? 1/4 minus, what do I get here? Negative 1/4, which equals 1/2. So using our fundamental theorem of algebra, or calculus rather. Let's look at number 47. Number 47. Number 47, they're asking us to find the area of the shaded region. The area of the shaded region. Now remember, when I take the integral, I'm finding what?
Area under the curve.
Area under the curve?
In between the curve and the x-axis.
Between the curve and the x-axis. So I hear the shaded area is above the curve. So how are we going to find the area above the curve?
Area of the rectangle minus area of cosine. Or the.
Correct. So the area of the rectangle minus the area of the curve. So we're going from 0 to pi. The rectangle would be
2 pi.
2 dx. We're going to set up the integral. Minus the integral from 0 to pi of 1 plus cosine x.
It wouldn't the area of the rectangle be 2 pi?
It's going to be 2 pi, yes. But we want to set up, we want to get used to setting up the integral. Because what did I get here? What's the integral of 2? Integral, antiderivative of 2? 2x. What's the integral of 1?
X.
And cosine x?
Sine x.
So here we get 2 pi minus 0, which is 2 pi, minus, oops, pi plus Sine of pi is
Zero.
0 minus 0. Sine of 0 is 0. So we get 2 pi minus pi, which equals pi. So this is how we're using the fundamental theorem at calculus. Let's look at number 57. Let h of x equals the integral from 0 to x of ft dt, where f is the continuous function with a domain 0 to 12, graphed here. Find h of 0. H of 0.
Is it just 8?
What's that?
Is it just 8?
No. If I'm looking for h of 0, what are they telling me the x is? 0. So what is the integral from 0 to 0 ft dt?
Yeah, wouldn't it still be 0?
Yeah, it'd be 0, correct.
I was looking at the graph, not the right thing earlier. I just-
Correct. But everybody understand that? They say h of x equals the integral from 0 to x of f t dt. Is that correct? Is that right? Is that right? Yes. So when they say, what is x of 0, they're saying x is 0, so what do? Put 0 for x. And when the limits are the same, then we have a area of 0. On what interval is h increasing? What interval is h increasing?
9 and 12.
On what interval is h increasing?
From 0 to 0? Or from 0 to x?
Increasing means what?
It's going up.
Slope.
But again, remember, we're looking at integrals here, though. Alright, so basically this is, h of x is the derivative, or the antiderivative, rather. So I'm looking at the area. Where is the area positive?
So greater than x.
0 to 6. Alright, on what interval is the graph of h concave up?
6 to 12.
Concave up.
6 to 12.
Wait.
No? Hmm.
That concavity came from where? Where does concavity come from?
The slope.
Second derivative.
Second derivative. So if the graph I have here is the derivative, correct?
Mm-hmm.
My second derivative would be what? What would my second derivative be talking about? If the graph I'm showing, the graph that I'm showing there is the derivative of the function, correct? Would everybody agree with that? H of x equals the integral of ft dt, which my y would equal f of x. So that is the derivative. So therefore, I want to know where am I concave up? So I'm looking at the second derivative. So therefore, if I'm looking at the second derivative of this, I'm gonna be looking at what on the graph?
The positive or negative?
What's that?
Rate of change.
Rate of change means what?
Or the,
Slope.
yeah.
I need it concave up means the slope has to be what?
Well, doesn't the graph have to go from negative to positive?
But remember what we're looking at. This graph here is the derivative graph, not the function graph.
Right.
So yeah, so if this was a function graph, I would be increasing, decreasing according to the slope, and I would be concave up, concave down according to the second derivative. So derivative of this is the slope. The second derivative would actually be at the zeros. Where my tangent line is 0, see? If I was looking at the function graph. But I'm looking at the derivative graph. So the slope of the tangent line is my second derivative. Alright, so again, this is my function. Alright, I want to know where is my graph increasing or decreasing. Well, I can tell by of the tangent line, right? So that means from here to here, my slope of the tangent line is negative. Second derivative tells me what? Concave up or concave down. Usually gives me a point of inflection, correct? Where I change from concave up to concave down is my second derivative. But if I change this to a derivative graph, right, now my increasing, decreasing is not coming from tangent line, but is coming from integral. Where am I positive? Integral. That would be the area. So that means from here to here, my main graph is increasing. From here to here, my main graph is decreasing because my integral is negative. Well, if this is my derivative graph, then my tangent line would be my derivative of my derivative, right? Derivative of my derivative means what? Second derivative. So where am I concave up? Where is my second derivative positive? There.
6 and 12.
No.
No.
12,
12.
Look at that graph there. Where am I positive? 9 to 12. That's where I would be concave up, because that is the derivative of my derivative. Second derivative. Is h of 12 positive or negative? H of 12 positive or negative? How do we know?
Well, you have to, well, you plug 12 in for x, so from 0 to x. And then what you have to plug in, or take the derivative of the function.
But again, we don't have a function equation, we just have a graph. Remember, h of x equals what? The integral. Integral represents what? Area. So, h of 12, that means going from, as you said, putting 12 in for x, from 0 to 12. Is it positive or is it negative?
Is the area positive?
That's what h of x is, right? Is the area from 0 to 12 positive or negative?
Well, wouldn't we have to take the area from 0 to 6?
No, we're not looking for the total area. We're looking for the integral. The integral is not total area. If we wanted total area like we did earlier, we would have to split it up. But here we don't. We just want to know the area from 0 to 12. What am I looking at? I'm looking at both areas that I have. What is the area from 0 to 6? Positive or negative? Positive. What's my area from 6 to 12?
Negative.
Negative. What do they do to each other? They will cancel each other out, right? All right. Now we would get 0 if the areas were what?
The same.
The same. We would get positive if the area that was positive is greater than the area that was negative, correct? We would get negative if the area that was negative is bigger than the area that was positive, correct? So in this case, would h of 12 be positive or negative? Positive, because this area is bigger than this area. So h of 12 would be positive. What if I said h of 6? Would h of 6 be positive or negative? Positive, because it's all above the x-axis. Okay, so that's what they're looking at. Where does h achieve its maximum value? Where does h achieve its maximum value?
Can we say from 0 to 6? Or does that have to be 1 point?
It's 1 point.
Well, wouldn't 1 point, wouldn't the area be wouldn't it be 0 anywhere?
What's that?
Wouldn't the area of, if the area was
But
only
again-
at 1 point, wouldn't it just be 0?
No. Where does h of x achieve its maximum value? Now again, h of x is talking about the function, correct? Because h of x is the integral of f of t, which is the derivative. So I'm looking for at the function. Where does my function achieve its maximum value?
So at x equals 6.
At x equals 6. Because what is the function doing from 0 to 6?
It's positive.
It's positive, so what is the function doing? Increasing. After 6, what is it doing?
Decreasing.
Decreasing. So here, where does h achieve its minimum value?
At x equals 12.
X equals 12. Because we went up, 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 and then we started coming down, 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 down. Did we start going back up again? No. So therefore, at 12, I'm at minimum. Now, it could be just a local minimum, may not be a maximum, a absolute minimum, but it could be just a local minimum. And that's what they're talking about there. All right. What's that?
Would it be at 0 too, or?
Not necessarily, no. Not necessarily. All right, look at number 59. All right? In 58, 59, the differential function whose graph is shown is given in the figure. The position at time t seconds of a particle moving along a coordinate axis is s equals the integral from 0 to t of f of x dx. Use the graph to answer the question. Alright? Now remember, the graph we're looking at is the derivative graph. Derivative graph of what? What does S represent? What does S represent?
It's the integral of the derivative.
But what does it represent when we talked about motion in calculus? S.
Oh,
No,
acceleration.
Oh, wait,
No.
Velocity.
no.
Distance.
Particle motion.
Position.
Ah.
Remember, when we first started talking about derivatives, if this was position, alright, how did I figure out the displacement? The area underneath the curve. How did I figure out the velocity? Derivative. How did I figure out acceleration? Second derivative. So when they say S equals the integral, right, of f of t dt, well, the graph I'm looking at is the derivative. And my position is the area underneath the curve.
So f of t dt, or f of t is the derivative, but since you took the derivative, I mean, they took the f of t is the derivative of the derivative, but since you took the
Now,
antiderivative.
f of t is the derivative of my position function. Alright, because they say S equals the integral, the antiderivative of this. So if this is velocity, then this has to be, the antiderivative of velocity is position.
Okay.
Alright, so you gotta remember those. Alright, if I have a position, I take the derivative, I get. If I have a position equation, I take the derivative, I get.
Area integral.
If I have a position equation and I take the derivative of that position equation, I have what?
Velocity.
Velocity. If I take the derivative of a velocity equation, I have acceleration. If I take the derivative of an acceleration equation, I get
Jerk.
jerk. How dare you call me that? Alright? So if I take the integral of a jerk, I get
Acceleration.
acceleration. If I take the integral of acceleration, I get
Velocity.
velocity. If I take the integral of velocity, I get position. So they're saying S is equal to what?
FTDT.
The integral of this. So that means that this must be what? Velocity. Because S is position. Okay? So keep that in mind. Letter A. What is the particle's velocity at time t equals 3? Remember, what are we looking at? What's the graph?
That is position.
No. Look what they say. Y equals f of x. This is what? If this is position, then this is velocity. So what's the graph I'm looking at?
Velocity graph.
Velocity graph. So what is the particle's velocity at time equals 3?
0.
What's that?
Oh, wait, at 3, it'd be 3.
Ken, what did you say?
0.
0. What does the graph equal at 3?
Oh, I'm looking at the wrong one.
Yes, okay. So 0. Is the acceleration of the particle at time equals 3 positive or negative?
Positive.
Why?
Slope is positive.
Absolutely correct. The slope is positive. Because I'm looking at a velocity graph, So my acceleration would be the derivative, which is the slope of the tangent line. You're getting it. Letter C. What is the particle's position at time equals 3?
At 0.
No.
Oh.
Because position, I gotta look at what?
Antiderivative.
Antiderivative, which is represented by what? Think about the graph. If I have I got velocity, and I want to find position, what do I have to look at?
Area under the curve.
Area underneath the curve, correct. So I'm looking for the position at time equals 3. So I need to look at the
From 0 to 3.
from 0 to 3. And what is the area there?
So it's negative.
Negative what?
It's negative.
What's that?
Negative 9.
Negative
Yeah.
9, correct. Because I have a triangle, correct? Everybody agree?
Yes.
1/2 base times height. All right, base is 3, height is 6. So, and it's under the curve, so it's negative 9. When does the particle pass through the origin? When does it go by 0? Because at 3 I'm at negative 9. When do I get back to 0?
I'm assuming it's at x equals 6, because the areas will cancel each other out.
Absolutely correct. So x equals 6. Alright, so we're looking at the area again for position. Approximately when is the acceleration equal to 0?
Is it 7?
What's that?
Is it 7?
Correct. Because again, acceleration is derivative of my velocity, correct. When is the particle moving toward the origin? When is the particle moving toward the origin?
From 7 to 9. Well, to 9. I guess x equals 9.
Again,
Or t.
when it's moving toward the origin, I'm looking at what? What do I need to look at?
Area.
No. Area position. I'm looking at,
Velocity.
that's how I know if I'm moving forwards or backwards, correct? So I gotta look at velocity. So therefore, I'm looking at when will it be moving toward the origin.
When it's negative?
When what is negative?
The velocity? So,
No, because if the velocity is negative, that means I'd be moving backwards, right? Moving away. So I need to know when the velocity is. Look, if I'm moving in a positive direction, my velocity should be positive. But if I turn around, my velocity now is, when I'm turning around, my velocity is 0 because I'm stopped. Then now I'm moving back away the other direction, my velocity should be
Well,
Negative.
negative.
velocity would be negative, sorry.
Okay? Again, what is the graph I'm looking at?
Velocity.
Velocity. So if I want to know where am I moving toward the origin, is that what it said?
Yes.
Alright? I should be looking for a velocity that is, I think I can,
Negative.
negative, correct. Is that what we said before earlier?
yeah, I said that.
You said that.
Yeah.
I had the wrong question in my mind, so that's why I messed you guys up. So yes, if I'm moving back toward the origin, I should be looking at a negative velocity? Everybody agree?
Yeah.
Are you sure? Okay, so where am I moving toward the origin?
So from 0 to 3.
Okay, so let's think about this. Where did I start?
That's a good question.
Where would you assume the particle started? Grace, where would you assume the particle started?
It's 0.
At 0, correct. Okay. What is the velocity in the beginning?
Negative.
Negative. So what am I doing? If I'm starting at 0 and my velocity is negative, where am I going?
Going back.
I'm going backwards. I'm going away from the origin. Okay? So when my velocity turns positive, then I'm doing what?
And positive
But am I going, where am I going though?
to the
Origin, correct? When do I go past the origin?
when the position is gets positive.
Okay, my displacement is, all right? So here's my number line. Here's 0. Go this direction. And then I turn around and go this direction. Going away, going toward, but once I passed it, now I'm going back away, but my velocity is still positive. But I'm going away. So here, that's what they're asking us. When is the particle moving toward the origin? From where?
So from, I want to say 3 to 9, but
Is it 7 and 9?
All right, so let's look at this. At 3, time equals 3. Time equals 0. Time equals 3, where am I at?
0.
Time equals 3, what did they say my displacement was? What did we say our displacement was?
0.
No, we didn't say that. Look at the graph again. Displacement is what?
Change in distance.
But as far as looking at the graph, remember, this is a velocity graph. Correct? Displacement, we talked about area under the curve, correct? Because this is time and this is velocity. What is velocity times time?
Distance.
Distance. So the area is distance. So from 0 to 3, what is the distance? Where did I go? What is the area under the curve from 0 to 3? We answered that question back earlier. Negative 9. So where am I at? If I started at 0, I'm now at negative 9, t equals 3. Where am I at? How far did I go at t equals 6? From 3 to 6, how far did I go?
Positive 9.
Positive 9. So now I'm back here. T equals 6. Okay? So, from 3 to 9, which direction am I moving?
Positive. Well, right.
I'm going positive direction, correct?
Yeah.
T equals 6. T equals 9. I'm not sure where exactly I'm at. So, went this direction, and keep on going. So where am I moving towards the origin?
From 0 to 6.
You have 9 to
Or-
0.
I'm going, here's my origin here. I'm moving toward the origin. So from 3 to 6. Where am I moving away from the origin? 0 to 3, 6 to 9. Right? So we'll look at some more of this on Monday. What I want you to do this weekend, though, I want you to do on page 302, numbers 2 through. No, I take that back. Let's do page 302, numbers 2 through 26, every other even, and 28 through 48. Even. Okay? 2 through 26, every other even. 28 through 48, even.